Hello and welcome to this Quarkus course. My name is Leonid and this is the first lesson where we will overview our project. So let's start from my screen. I will share my screen. Here you see a web application that is called Indoor Position Tracking. So in this web application, we see moving cats, cat 01 and cat 02. You can see floor plan. So this is my flat where I currently live. I have created this floor plan using application. I will show you how it's called so you can do the same thing. And here at the right, we can see speed of our cats, alert zones, and alerts that we received. So the main idea is to track something indoor. I will track my cat. You can track your dog, your brother, your mom, whatever thing or person or animal or pet you want to track. So we will use this device that is called AI Thinker DU03 kit. We'll use this technology because we cannot rely on GPS indoors. GPS, when we use GPS indoor, it's have a very big margin of error. It's around 10 meters. So for example, if I open my phone now, I will see myself outside of the building. So to track something indoor, it's impossible. Instead, we want something more precise. As you can see from the screen, I want to know like in which room my cat is right now. I want to have like a centimeter margin of error, not 10 meters. So that's why we'll use this technology that is called URL. We will need not just one device. One device we will put on our animal to track, and we also need other 4 devices that we will put in the corners of our flat. So as you can see, my flat is like a square shape. So I will put 2 devices in up corners and 2 devices in the bottom corners. And so in the middle, we will have our cat that will be moving and he will wearing this tag, this device. How this technology works? These devices basically exchanges a radio signal between them and they calculate time of flight. Base the time of flight of radio signal, these devices will calculate the distance. So we can know the distance between 2 devices. If we have more devices like in our setup, we can also calculate coordinates using geometry. This is a Quarkus course, but I have wrapped it in something interesting. So we will not just learn theory, speak about Quarkus, we will apply Quarkus on a real project. So this project is built using the microservices. The web interface is built using Nuxt UI, so we will cover different topics from native compilation, why Quarkus, why we have choose Quarkus to build this project. So let me just preview what is happening on the backend. This is setup that I have bootstrapped in a weekend. So you just see some services running. We have a simulator that is sending cat's position. So this is a lot of main important things for those of you who don't want to mess up with IoT stuff and these devices. We will create a simulator that will produce cat's positions constantly so we can develop something without hardware. As you can see right now, hardware is not connected, but still inside the web application, we can see some data, we can see moving cats, we can see alerts to be generated. So this is why we use simulator. Okay, so now let's start from overviewing the main component that we need to build this system. Let's start from the left. So here we have a Raspberry Pi Edge, and we have this arrow that is publishes positions data. So as I said, for those of you who want to follow me in every step, we'll use UB tags. This tag must be attached to some microcontroller or mini computer like a Raspberry Pi. I will use ASP32. You can use Raspberry Pi if you already have. So we just need to read serial data from this device and to push this data to our system. Another main component is Kafka cluster. So we will use Kafka cluster because our microservices are event driven. So our events will be published to Kafka. So each position that we will generate from simulator or create or read from this device, we will create a dedicated event in our Kafka cluster. So Kafka is our message broker. The next actor is pet owner. So it's our users. So everyone who will have access to our platform is considered a user. As an end user can view this application. It can create draw algorithm. For example, I have created these results. You maybe for your setup, for your flat, want to create another zone here in Langry. So just to show you. So here we are trying to create another zone. So this is our user will have this possibility to interact with our platform like that. In the needle, we have our main platform. So SIA as a needle will have our core. So all of our microservices, our backend logic lived here in our pet tracker platform. At the right, we will have also Keycloak. We'll have a dedicated module where I will show you how to attach Keycloak, how to set up Keycloak. So all of our microservices are protected. No one from outside can just create you a request without a token. So we'll learn how to do that. The last thing that we will need is a database because we want to store positions and we will use mobile database for that. So we will also learn how to communicate with a database from Quarkus services, how to use a Palacio reactive library. And yes, so this is a big picture. Now let's go more in detail. So here we have a more detailed view of our architecture. So here basically we're viewing this piece on the little pack tracker platform expanded, so we can see what we have inside really our platform. So we will have a web application. As I already shown you, this is a web application where user can see live cat's position, can create alert zones, can see its velocity, delete alert zone, and stuff like that. Next, so our application is receiving this data in real time from a real-time gateway. As you can see here, we have a dedicated microservice that is called real-time gateway that is pushing this data via SSC to our. So if I go to inspect here and I go to network tab, I refresh this page, I must see here you see this is event stream. This is SSE event stream. So here we're seeing tons of messages right now, real time, and we are translating those messages to cat movements on our fork one. So this microservice is responsible to push data to our web application. So here we see how it actually pushing it right now. The next microservice is called API Gateway. What this microservice has scope to route our data. So as we said, our UB devices give us exact position of our cat. So here we have a Raspberry Pi Edge and we have a simulator. So both of them can push the positions into our system and they will push those positions talking with API Gateway. So API Gateway is a service that exposes a REST API. This REST API can be called by a Raspberry Pi or by a position simulator of Quarkus microservice. And the main responsibility of this microservice is just to route this data to another microservice. So we let's keep it is as simple as possible. So we just only route data to the another microservice that is called data ingest service. So let's see it more a little bit in detail. What this service is blue. This service is only pushes data to the Kafka. So you may ask why we are not pushing data to the Kafka directly from API gateway. This is a very good question. As the answer is, you can break a single responsibility. As we said, a responsibility of our API gateway is to route traffic. If we will route traffic and we will write it up to Kafka, we will have more than one responsibility we have choose to this service. So that's why we are creating another dedicated microservices that will responsible only to produce this data to our Kafka cluster. After that we have data in our Kafka cluster, we can consume it and process. During this processing, we can calculate the speed of our cat, so how fast is our cat is right now, and this calculation will be done by event processor. So this microservice is currently over overloaded, but we are doing it for learning purpose, so we will then decouple it. So here this microservice is calculating the speed. This microservice is creating also alerts, and this microservice at startup will execute get request to the zone management service to receive zones that we have created. So for example, here I have created 3 zones. The data about the polygon, the coordinates of these zones are staying inside the zone management service in its database, okay? But our event processor, when processing events of the position, should know when to fire this alert. So for example, here kept 001 is moving, and now we have received this alert, and this alert was fired by event processor. So this microservice has more than one responsibility right now, and that later we'll see how to improve it, how to improve this request, how to avoid in-memory caching, what problems we'll have with in-memory caching. And okay, let's move forward. Next service is a position writer. So here we have a position writer. From the name, you can understand this service has a responsibility to write data to our database, nothing else. So it consumes messages from Kafka and writes them to the database. Why we are doing this? Because then later we can scale differently our reading service. The query service is a service that actually will read the data from database, and this position writer is the service that actually only writes the data. This pattern is called, we will use SQL as patterns, so we will divide from commands and queries. So our command is a service that actually writes data, and our query service actually that reads the data. Here we have multiple database setup. In our learning setup, we will have only one database, just to show you how it works. So we have this division. This command service is our writer position service, and this is our query service. As we said, we also have zone management service that is responsible to manage zones. What are zones? Zones are these red areas that we decide. When cat enters in our zones, we want to receive alerts. For example, these zones are critical and I want to be notified in real time when cat enters the zone. For example, you have a balcony that is not protected. Maybe you have something dangerous in laundry or in the kitchen, so you just desire this zone and you will receive the alert when cat will enter this zone. And yes, I think we covered all of the services. And so thank you and see you in the next lesson.